All right, guys, so we're going to go ahead and now look at how we use these balanced chemical equations to do calculations of the chemistry that's happening. Okay? So basically, what is the purpose or what is the reason behind actually balancing this? So it's because we want to be able to calculate quantities of products or reactants needed to carry out a chemical reaction. So if I'm going to set up a chemical reaction, I need to know how much of everything I need, and I want to be able to predict how much I'm going to make. Okay? So that's what this balancing does for us. It allows us to do that. So we need a balanced chemical equation to be able to do this. Okay? The coefficients represent the numbers of moles. So here I have 2H2 plus O2 produces 2H2O. Is this 2 grams of hydrogen and 1 gram of oxygen? It's not. It's 2 moles, right? It's 2 moles of hydrogen and 1 mole of oxygen to produce 2 moles of water. So the balanced chemical equation is not given in gram quantities. It's given in mole quantities. Okay? Because that helps us see actually as well the number of atoms. 1 molecule of hydrogen would react, 2 molecules of hydrogen would react with 1 molecule of oxygen on the atomic level. So, but on the molar level as well, it's 2 moles of hydrogen and 1 mole of oxygen. Okay? Which are the quantities that we can work with. We need it in big quantities, molar quantities, so that we can work with it. Okay? So that's how we're going to use these chemical equations, by their coefficients, which represent the moles of the substance. Okay? So when we carry out these chemical equations, it isn't those molar amounts due to their coefficients. Okay? So let's examine this water reaction here. 2 moles of hydrogen plus 1 mole of oxygen produces 2 moles of water. Okay? So the coefficients tell us the molar amounts. So what if 4 moles of hydrogen reacts with 2 moles of oxygen? Okay? How much water does it produce? 4 moles of water, right? So 4 moles of H2 and 2 moles of O2 produces 4 moles of water. Right? What if it was 0.87 moles of H2? How much water would I make? Good. What is it? He was right. Okay, let me ask the question again. Is everybody listening? Okay, so if I have 0.87 moles of hydrogen, H2, how much water, how many moles of water will be produced? Right? Look at the relationship between hydrogen and water. They're the same, right? I have 2 moles of here, I have 2 moles here. If I have 2 moles of H2, I make 2 moles of water. So if I have 0.87 moles of H2, I have 0.87 moles of water that I produce. Okay? So that's what this is helping me see. Well, how much oxygen would react with that? For every 2 moles of H2, I have 1 mole of oxygen, right? That's half the amount, right? That's half. 1/2 of this. So 0.87 moles will react with how much oxygen? Right? So half of it, right? Now, let's look at that in a different way. If I have 0.87 moles of H2, and I want to know how much O2 will react with it, then I want to convert from moles of H2 to the moles of O2 from the moles of H2. Okay? Well, according to my balanced chemical equation, how many moles of H2 do I have?
0.87.
No, look. 2 moles of H2 for 1 O2. So 0.87 times 1 divided by 2 will tell me the moles of O2. This becomes a conversion factor. It becomes a way for me to convert from the moles of one thing to the moles of another thing. Okay? So exactly half the moles of this are how many moles of O2 I need. All right? That's what my balanced chemical equation is telling me. It's telling me the relationship. Let's set it up for moles of H2 to the moles of H2O from the moles of H2. What's the molar relationship? How many moles of H2O for how many moles of H2? According to my balanced chemical equation. 2 for 2. So what's my answer? Exactly. Okay? So if I have 0.87 moles of H2, I have 0.87 moles of H2O, because these will cancel, right? And I'll be left with this. 0.87 times 2 divided by 2. 0.87. Okay? All right. How many moles of O2 are needed to react with 4.26 moles of H2? How am I going to set this up? I start with 4.62, right? 4.26, excuse me, moles of H2. Okay, line thingy. That's very technical.
And you do put moles O2 on top and moles H2 on bottom.
Good. And where am I going to find that relationship?
Up on top. In your balanced equation.
In my balanced chemical equation from up top. Okay?
2-1, right?
So how many moles of O2?
2-1. I mean 1, sorry.
How many moles of H2?
2.
2. So what's my answer?
2.13.
That's how many moles of O2 are needed to react with 4.26 moles of H2. Right? Okay? So that's what we're going to see here. So we set it up correctly. So I just use my balanced equation to allow me to find the relationship. It helps me find the relationship. Okay? So it's just simply a conversion. That's what we're doing. And the conversion factor comes from the chemical equation. But what units does my question have to be in to answer it using the balanced chemical equation? Moles. It has to be in moles. If I had started with grams, could I do that relationship in grams? No. I could convert it to moles from the grams and then do it, but I couldn't go grams and do the molar relationship to go to the moles of the other thing, right? I can't do that. The units don't match. So I have to start in moles so I can convert to moles from the grams, and then I could go forward. All right. So that's useless. Let's go here. Okay. So here I have C3H8 plus 5O2 produces 3 carbon dioxides and 4 waters. Okay? So 5 moles of O2 is consumed, 3 moles of CO2 is formed, and 4 moles of H2O is formed. And I can get the molar relationships between C3H8 and O2, or C3H8 and CO2, or C3H8 and H2O. I can relate them all to one another. Okay? So they can all come together. These are the conversion factors of the chemical equation. Okay? They help me convert from one thing to another thing, or from here to here, or from here to here. I can go any which way I want, as long as I know their molar relationships. Okay? Calculate the grams of O2 reacting with 1.00 moles of C3H8. Okay? So, I'm starting with moles of C3H8, and I want to go to the grams of O2. So, I need to map out in my head the process. Moles of C3H8, and I want to go to O2. So I can't go from here directly to here, to grams. First, I have to convert from the moles of C3H8 to the moles of oxygen. That's my first step. So from here to here, and then I can convert to grams of oxygen. Okay? But that conversion is just what we've always been doing. This part right here, this is the stoichiometry. That's what we call this. We call it stoichiometry. Stoichiometry is the process of converting from the moles of one thing to the moles of another thing using a balanced chemical equation, which isn't right here, but if it was, I'd point at it. Okay? So, using a balanced chemical equation. All right? So I have to have that balanced chemical equation to do this process. Moles of C3H8 to the moles of oxygen. Okay? Yes, ma'am.
Can you go back to the balanced equation?
Sure, I will. Okay? There we go. Using a balanced chemical equation. Okay? So, that's my balanced chemical equation. So we can see all the relationships here. Oh, yeah. Nobody's counting. Okay, so we can see that that's what they did here, right? They took 1 mole of C3H8. They converted it to the moles of O2 using the relationship. 5 moles of O2 for every 1 mole of C3H8. And then they did a second conversion, going to the grams of O2 from the moles of O2. And they get 160 grams of O2 produced. Okay? So we need 160 grams of oxygen to react with 1 mole of C3H8. Okay? Calculate the grams of carbon dioxide produced from combustion of 1 mole of C3H8. So once again, I'm going to go from the moles of C3H8 to the moles of carbon dioxide, and then I can convert to the grams of carbon dioxide. This is the stoichiometry. Mole to mole conversion. That's the heart of what we're doing. Converting from one thing to another thing. And I can only do that in moles. But once I'm in carbon dioxide, I can go from the moles of carbon dioxide to the grams of carbon dioxide through a simple conversion that we learned earlier, right? Grams to moles or moles to gram conversion. So here we're going to take 1 mole of C3H8. We're going to multiply it by a conversion factor of 3 moles of carbon dioxide for 1 mole of C3H8 times 44 grams of carbon dioxide for every 1 mole of carbon dioxide. Does everybody know where this number came from? Okay, so this right here, this conversion factor, okay, if I'm going to convert from the moles of carbon dioxide to the grams of carbon dioxide, I have to find this relationship. For every 1 mole of carbon dioxide, how many grams are there? Where do I find this amount? Where did it come from? Good, the periodic table. Okay, carbon has a mass of 12, oxygen times 2. Well, my pin's not right. 32. So we have 44 grams per mole. Okay, so that's where the 44 is coming from. It's coming from the periodic table. So whenever I have units of grams in my conversion factor, where do I find those units? I find them there. Okay? Okay? Calculate the grams of C3H8 required to produce 36 grams of water. So let's map it out. What am I starting with? The grams of water. That's what they gave me, right? 36 grams of water. So, how am I going to convert from water to C3H8? Can I do it in grams? Can I go 36 grams of water to the grams of C3H8 in one step? Can I do that? I can't do that. Because I can only convert from one thing to another thing in what units? Moles. Moles. In moles. Okay? That's the stoichiometry step. Moles of water to the moles of C3H8. This other stuff right here, this isn't stoichiometry. That's simply so that I can do this. I'm going to convert from the grams of water to the moles of water so that I can perform the stoichiometry. Once I know the moles of water, of C3H8, I can then convert to the grams of it to answer the question, because the question wants to know the grams of it. So that's the process. I map it out. Grams of water to the moles of water, from the moles of water to the moles of the other thing, C3H8, then to the grams of C3H8. Okay? That's the process I'm going to follow. So I start with my grams of water. I multiply it by this first conversion. 1 mole of water for every 18 grams of water. Do we know where this 18 came from? Oxygen has a mass of 16. Hydrogen has a mass of 1. 2 hydrogens has a mass of 2. 16 plus 2 is 18. That's where that 18 came from. Where did this come from, the 1 to 4 relationship? From the balanced chemical equation. 1 mole of C3H8 produces 4 moles of water. That comes from the balanced chemical equation. 4 waters for every 1 C3H8. Okay? That's where that relationship comes from. So whenever I have a mole-to-mole relationship, whoops, I'm going backwards, not forwards. Okay? Whenever I have a mole-to-mole relationship, it comes from where? The balanced chemical equation. That's where I find it. This is grams and moles. Grams is found where? Moles is found, it's always 1 when it's with grams. Okay? Grams and moles are 1 when they're together. Moles and moles, balanced chemical equation. Grams and moles are always 1. Okay? Okay, so before we get into this one, I actually want to draw another one. Let's just take an example from our equation sheet here, the balancing equation sheet. I like number 9. Okay. So if I have 0.63 moles of C8H18, how many moles of O2 will react with it? It's not half of it. Look at the coefficient of O2. 25 for every 2. That's a different ratio, right? So let's set it up. 0.63 moles of C8H18. And I want to convert it to the moles of O2 from the moles of C3H18. What number goes on top? 25 moles of O2 for every 2 moles of C3H18.
7.87.
So, if I have 0.63 moles of C8H18, I need 7.87 moles of O2 to react with it. How many moles of carbon dioxide would be produced? Okay, I'm starting with the moles of C8H18, and I'm going to go to the moles of carbon dioxide from the moles of C3H18. Okay, what number goes on top? What number goes on bottom? That's the relationship, right? 16 moles of carbon dioxide for every 2 moles of C3H18. That's how I'm going to convert that. What does it come out to be? Now, let me ask you a question. Would this number, 5.04 moles, be any different if I had started with 7.87 moles of O2? Let's find out. 7.87 moles of O2, and I'm going to convert that to moles of carbon dioxide from the moles of O2. How many moles of carbon dioxide? How many moles of O2? Okay, what do I get?
5.03 or 0.4 if you want to.
The same. Okay, I get the same answer. So it doesn't matter where I'm going from. From here to there or from here to there, I get the same thing. Yes, ma'am?
Where did you get the C3 from? On the first two steps.
C3. Did I write C? Oh, did I write C? I'm sorry. Yes, that was a typo. Or a righto. Yes.
Didn't you get the 0.63 in the beginning? Like, would that be given to us?
Yes. So they would have said, you have 0.63 moles of C8H18. How many moles of O2 are produced? 7.87. How many moles of CO2 are produced? 5.04. Okay. Now let's answer the last question. How many moles of water are produced? And you can use any of these 3 numbers to determine that. I could use 0.63 moles of C8H18 or 7.87 moles of O2 or 5.04 moles of CO2. And I will find the same answer. Okay? So, how many moles of H2O? Go ahead. How many is it? How many moles of H2O are produced? You have 3 choices. Doesn't matter. They'll all be the exact same answer. Yikes. Is that what everybody's getting? Is there a consensus on that? Okay, so I could have started with 0.63 moles of C8H18 and gone to moles of H2O from the moles of C8H18. 2 for every 18. Or I could have started with 7.87 moles of O2 and converted it to the moles of H2O from the moles of O2, 18 to 25. Or I could have started with 5.04 moles of CO2. I would get the same answer. Okay? I would get the same answer. So, were we all getting 5.67? Good. Okay. So that's how I can relate all these by moles. through the chemical equation. Okay? Now, what if the question was, you start with 7.87 moles of O2, and they want to know how many grams of carbon dioxide are made. Well, the first process is the same. I still have to do this process right here of going from O2 to CO2, but then I can take it one step further. Well, after I convert to the moles of CO2, I can now convert to the grams of CO2 from the moles of CO2. What number do I put right here? Moles of O2. If it's gram to moles, moles are always 1. Grams are 44. Okay? 7.87 times 16 times 44 divided by 25. Okay? That's how many grams of carbon dioxide would be produced in this chemical reaction. 200 what?
221.62.
Okay? Which would be 5.04 moles. Okay? All right. So, let's do a different question. So let's try another reaction here. Okay? 2 KClO3 produces 2 KCl plus 3 O2. Okay? So I want to go, let's say you have 2.98 grams of KClO3. How many grams of KCl would you make? So I want you to work that out for a minute and see if you can figure it out. And then we'll set it up together. Think about the process you want to follow to get there. And this KCl needs to be in grams. How many grams of KCl? I haven't calculated it. Did you already do it? Okay, we'll calculate it in just a minute.
No?
Are those number twos? Are those in gram quantities?
Can you go back to the other example where it has
Okay. Well, first, I can't go from grams to grams, right?
No.
Directly.
Yeah, but you need to go to moles.
Okay. So how do I go from grams to moles?
So you do grams, moles,
Grams to moles to moles to grams. That's not moles, that's grams. Can I use that 2.98 with the chemical equation? No, I can't. So I have to change it, right? So you need to change it from 2.98 grams to what? There you go. That's your first step. Okay, so yes, you have the right idea, but the units are a little off. Like this would be grams of KClO3 instead of KCl. This is moles of KClO3. This would be moles of KCl.
Oh, okay. We could set up.
But you have all the numbers right.
I was trying to look at this one. Was it?
Okay, so let's go ahead and look at the process. So I'm going to start with my 2.98 grams of KClO3. My first step is that I want to convert that into moles of KClO3 because I cannot use it in grams to go from one thing to another thing, right? So that's my first step. Once I have converted to the moles of KCl3, then I can convert from this to this, from KClO3 to KCl. So now I'm going to go to the moles of KCl. Once I have converted to the moles of KCl, my final step to answer the question is simply how many grams of KCl is that, and I convert to the grams of KCl. This is my process. Okay? If you write the process along the top, then you know exactly what needs to go underneath because they just drop. All the units will drop. So what units go down here? Grams of KClO3. What units go down here? Moles of KClO3. What units go down here? Moles of KCl. Now I look at my relationships. I have a gram to mole relationship. In that relationship, the moles are always 1. Grams to moles, moles are always 1. Okay? What are the grams? Here, we'll start here. What are the grams of KClO3? What am I going to put there?
240, 163.
Whoa. Getting a lot of numbers, you guys. Okay? KClO3. It's 39. 35.5. And 16 times 3? Okay, so what are we going to get? 160. Boy. Yeah, where's my calculator? Okay, I think that's what it is. Okay. No, it's fine. You can keep all the decimals, that's fine.
I thought you would have to multiply the KCl by 2 since you have 2 KCl.
Oh, good. You don't. do not do that because, so this is 122. I'm glad you brought that up because that happens all the time, and I want to clarify that right now. You don't do that because guess what I'm going to put right here?
2. 2.
What am I going to put right here?
2.
2. So that's when I multiply it by 2. But right here, I just simply need to know that for every 1 mole of KClO3, I have 122.5 grams. If I had multiplied it by 2 here, I would have to make this 2. 2 moles of this weighs this. 1 mole of this weighs 122.5. Okay? So, don't do that. Okay? Yes, just the mass of KClO3. That's what we want. Okay? Okay. Now, what is the mass of KCl?
74.5.
So my mass of KCl is 74.5. So how am I going to carry out this calculation? 2.98 times 1 times 2 times 74.5 divided by 122.5 divided by 2. Okay? So 2.98 grams of KClO3 will produce 1.81 grams of KCl when it decomposes. Yes, sir? Okay. That would have to be K and Cl, 35.5, and this is 39. Add them together. Okay? Okay. Add them together. Okay? So that's how we would do this. This is the longest it would ever be. Grams of one thing to the grams of another thing. Okay? But I could have started anywhere. I could have started with the moles of KClO3, and then I would have just do this part. Or if I had started, or if they asked for the moles of KCl instead of the grams, I would come here and I'd just go to the moles. I would stop there. Okay? So it just depends on what they're asking for in the question. Okay, so here's an example. Calculate the grams of HCl neutralized by 0.5 moles of calcium hydroxide. So I have 0.5 moles of calcium hydroxide, 0.5 moles, okay? And I want to calculate the grams of how many grams of HCl. So I'm starting here. I want to go here, okay? I cannot do that unless I'm in molar quantities, which I am. So I'm starting in moles. I'm going to convert from the moles of this to the moles of this, and then to the grams of that thing. So this will be my process. Moles of calcium hydroxide to the moles of HCl to the grams of HCl. So I start with my 0.5 moles of calcium hydroxide. I find the molar relationships, 2 to 1, and then I multiply by the molecular masses, 36.5 grams of HCl. So this times a half is also 36.5. So my answer will be 36.5 grams of HCl. Okay? So that's the process, right? This is showing a conservation of mass. Here I have calcium hydroxide. 1 mole of that is 74 grams per mole. 74 grams. 2 moles of HCl. Each one weighs 36.5. That's 73 grams. 2 times 36.5. So those together will be 147 grams of reactants. Over here, calcium chloride weighs 111 grams. Water, there's 2 moles of it. So 18 times 2, that's 36 grams. Add those together, I get 147 grams of product. So they're balanced, right? They have to be. That's why I have to have a balanced chemical equation so that I can relate them stoichiometrically from their moles to their grams. Okay? We're okay with that. So let's practice. Calculate the moles of chlorine reacting with 5 moles of sodium. Okay, so set it up. I don't care about the answer right now. All I care about is if you're setting it up correctly. So just try to set it up. moles of sodium to the moles of chlorine. 5 moles of sodium, how many moles of chlorine? Okay, so I'm starting with 5 moles of sodium, and I'm going to go to the moles of chlorine from the moles of sodium. What number goes on top? 1. On the bottom? 2. Whoops, I'm sorry. Did I just... Yeah, no, I'm right. Okay. 2 moles of sodium for 1 mole of chlorine. That's the relationship here, right? So 5 divided by 2, and I get 2.5 moles of Cl2. Okay? That's as easy as it gets. Doesn't get much easier than that. Okay? Calculate the grams of sodium chloride produced from the 5 moles of sodium. That reacts with, now this is key, okay? Excess chlorine. So, what does excess mean? It means it's not important. It has no bearing on this, because what's going to happen? 5 moles of sodium reacts with 2.5 moles of chlorine. So let's say there were 5 moles of chlorine instead of 2.5. I would never use all 5 moles, right? I would only use 2.5 of them. So this would get used up, and there would be extra chlorine left over. That's what we mean by excess. So this 5 moles is what tells me how much sodium chloride I produce, because it's the one that runs out. Excess chlorine means it's not going to run out. There's too much of it. So that's why this is unimportant. We don't need to know anything about chlorine or include chlorine in the calculation because it's in excess. Okay? So I'm going to start with my 5 moles of sodium. Now finish it. We're going to go to the grams of sodium chloride. You're welcome to. You don't have to. Okay, so I'm going to start here, 5 moles of sodium. I'm going to convert that to the moles of sodium chloride from the moles of sodium. And then I'm going to convert it to the grams of sodium chloride from the moles of sodium chloride. Okay? So those are going to be the processes I will follow. What number goes on the bottom here? 2. What number goes on top? Okay. Do you see why, right? Okay. What number goes down here? 1, because it's with grams. So it's 1 mole of sodium chloride. What number goes on top? 58. What's that? Okay, so 5 times 2 times 58.5 divided by 2. 290.
Oh, I did 58. I didn't do 58.
No, it doesn't. It's okay. Okay, 290 grams of sodium chloride. Approximate, right? You're getting around that? Okay, we're okay. So you'll find the answer, right? Okay, good. Calculate the grams of sodium reacting with 5 grams of chlorine. The grams of sodium, how many grams of sodium react with 5 grams of chlorine? You can't go directly to from grams to grams. What do you have to do first? Got to go to moles first.
Will that always be our first step, going to moles first?
If you're going to go from one thing to another thing, you can never do it in grams. So yes, that will always be your first step if you're converting to something completely different. Because you can only do that with a balanced chemical equation, and the balanced chemical equation is in moles. Okay? Okay, so we're almost out of time, so I'm just going to set it up. Okay? So hopefully this is what you were thinking. 5.00 grams of CO2, and I'm going to convert that to the moles of CO2, because that's how I can use my chemical equation, as if it's in moles. And then I can convert from the moles of CO2 to the moles of sodium. And then from the moles of sodium, I can go to the grams of sodium. Okay, drop my units, grams of CO2, moles of CO2, and moles of sodium. 1, 1, 35, 71. 71 grams of CO2 and 23 grams of sodium. Right? And my molar relationships are 2 sodiums for every 1 chlorine. Okay? So 5 times 2 times 23 divided by 71. That's what I would do to find the grams of sodium that would react with 5 grams of CO2. Okay, guys. We'll see you next time. Right here, is that what you're talking about? Moles of CO, 1 mole of CO2. Why do I do that? Over here? Because I'm not going to sodium chloride. I'm right here. I'm at CO2. CO2 for every 2